Nick Coubray, CEO of Howick, is the driver of the company's pursuit of innovation. He is the third generation of the Coubrays to champion this family-owned business that has been involved in framing technology and industry development since his late teens. After earning his stripes on the shop floor assembling machines, Nick went on to head Howick's UK office for 7 years, laying the groundwork which established the UK and Europe as Howick's largest export markets. He has also spent significant time with the U.S.-based customers and has taken the lead in a number of collaborative R&D projects, which eventually became customer feedback-led standard features across the industry. Nick has developed a deep understanding of the global construction industry and technology across Howick's global user base. From simple construction projects to high-tech installations, his focus now is on driving Howick's team to continue to evolve technologies for better building and in advocating for more efficient and sustainable construction practices throughout the industry. Nick lives with his wife and 3 children in Auckland, New Zealand. When he is not busy with family life supporting his children's activities, Nick likes to experiment with various creations using his 3D printer. It's my honor to introduce Nick Coubray.
So what I'm going to talk about today is 3 things, really. One is a really bugbear of mine, waste in the construction industry. Then some of the stuff that we're doing in software that's coming shortly. And then lastly, I'll show some of the other products that we make that are not framing but associated to framing, and some that aren't associated with framing. So the thing that really annoys me is waste. And when you think of construction, this is your typical thought. It's this sort of thing, or it's people standing around doing nothing. But there's actually a lot more to it than that. So a good example, so construction is probably one of the biggest generators of waste in the world. The traditional construction for certain is. And it's up to sort of 30%. So if you think of gypsum board, for instance, and that's one that we've been looking at quite hard in New Zealand. So what happens is you buy a lot more than you need because you don't know what you need because the site's not organised and there's all that sort of fun stuff going on. So you get to the end of the job and you might have 10 sheets, you might have half a pallet load left. So they've introduced this great recycling scheme where you pay the manufacturer to take it away, recycle it and sell it back to you. So again, wouldn't it be better just to do it right in the first place and not have all this extra? I mean, you're going to have a couple of sheets, but you're not going to have half a tonne gypsum board. And it goes for just about everything on the site. So, for instance, steel stud frame. So your traditional stud frame, stud and track comes to site in bundles and then someone goes and puts it together. So when we look at this, you've got transport to site. You've got reviewing the details of what you're now going to be building on site. Cutting and measuring parts and measuring out your layouts. Screwing them all together. The time it takes to actually sort and build those elements. Then you've got any delays because something didn't go right, which inevitably it does because you haven't planned. You've got all the waste and offcuts that then need to be taken away, again. So there's all these waste things that just build up to a massive cost. So now you compare it to our telescopic stud, and there's a few examples. There's some to the back and there's some at the front here. So it's made of 3 sections out of one machine, and the idea is it telescopes up and down and side to side. We can regenerate different shapes. So that planning is still important, but it's not as important because you've got some flexibility because every building is not what it appears. So you still got the transport to get it there. You don't have the plans because it's actually designed in the factory and made before you get there. There's no need to measure it because it's accurate. It's designed accurate and it's made accurate. You have to try to get it wrong. There's no cutting on site because it's telescopic. It all fits inside itself. You still have to screw it together a little bit because it has to go together. It's a hell of a lot faster. You don't have any delays because the panels are flexible. You don't have the waste you have to remove just from site because it's inside the panel, and that can be designed to be very flexible so you can have a much bigger and smaller panel, or it can be designed so you have just enough for those little inaccuracies, maybe a couple of inches, so you can take waste out that way. So that's a whole lot better than a skip full of materials and trucks and taking things to and from site. So an example of this is a building we've done that Hamish has worked on in Auckland. It's 1 Queen Street. It was a 5-star hotel and then an office tower on top of it. 150,000 square foot building, so right in downtown central Auckland. probably one of the worst places to get to and from. So we did this all telescopic panels on small trailers with a utility vehicle to tow these trailers in rather than big trucks. All the panels squashed down and they went in the service elevators up on the building, so there was no crane on site for any of our work. But one of the big things about this building was built in 1972. It's a fairly old office building that they've now turned into an intercontinental hotel, and it's Deloitte's new offices, so high specification finishes. So the telescopic panels were one of the things that helped them. They reduced the embodied carbon versus the new building, because the plan was knock it down, build a new building. Retrofitting this building reduced the carbon by 50% versus the new building, which is huge when you think about it, because there's a lot of these old buildings that we can refit. So the other thing on it was that the install of the framing, because it was telescopic, was 60% quicker than what they'd allowed for their traditional stud and track build. So again, we're showing complexity, a bit like Scott's saying. It's complex, but it's not complex, and that's where some of the real savings come too. So this is a typical sort of fit out, double T concrete flooring system. You've got a fire stop it. So normally doing stud and track, we got the customer to estimate it for us. He said 45 minutes to an hour to put that up. We went away and we made these little frames as modules, they're 10 foot long, and they're adjustable in multiple directions. Up on a scissor lift, installed in 2 minutes. So the labour waste is what we're really saving, because you can't get contractors. And this was built during COVID times, and they were only allowed 2 people per floor as part of the government restrictions. So they still got this building up super fast. Same thing again, this is one of our other products, strut for your mechanical support services. So the one you have on this side is, we're running traditional 6 metre lengths and bundling them up. They go to site and people chop them with saws and drill holes in them, and just traditional manual work. On this side, we're making them to length like the framing machine. It is the same machine in both, because we supply both ways out of New Zealand, but the whole idea is about 30% of that strut, again, is waste, because they have to cut it, they have to align holes. You want to make a 4 foot piece with a hole at 2 inches from each end, we can do that really easy. And you can make 10,000 of them, and they're all the same. So most of these commercial fit outs, the stuff is repeat, 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 but it's being done wrong. So again, waste. It's everywhere. It drives me nuts. We also do back-to-back strut. So thinking of the same thing, so product like this. Traditionally, this is black steel, not galvanised. It's spot welded, and then it's hot dip galvanised, which is a slow and expensive process. We can use pre-galv material and the riveting machine that we've developed, which is as strong as a spot weld, to put it together. So we can do them full lengths, partial lengths, with holes in them, without holes in them, and build up different elements. But we're really saving, again, we're saving time. We're saving that 2 weeks it takes to take that product and get it welded by a certified welder, and then get it hot dip galvanised, and then get it back, and then cut it to length. We can do straight off the machine and straight to these processes. While there's an investment in machinery, the back end saving is huge. That is traditionally used where you need high load capacity. Same thing in the mechanical electrical space, cable trays. So traditional way of making a cable tray, which you see here, is it's press brake, it's 2-man. They carry the sheet across, they put it in a press brake, they then take it out, turn it around, feed it back in. It's about an 8-minute process when we timed it for this customer. This machine, we feed the blanks in, and in 45 seconds, you've got a fully finished cable tray, and we can do it in any size you want. So there's the opportunity there to go a bit further and do a sheeting punching line, and you can then make any length you want to order. So it's these little things that the industry needs to move forward. The customer we built this for, it's been installed for 3 years now. It runs 24/7. And he's completely taken over the whole market in New Zealand of this sort of product, because no one can compete with them. So I mentioned software. One of the big things we're working on, and it's coming fairly soon, is our customer portal. So it will allow customers to log on, see the status of their machine, is there any service requirements, any manuals, any assembly drawings and all that sort of good stuff. And then we can do service notifications, and if there's faults, you can do support tickets direct from the machine to us. The next part of that is obviously production data. Everybody wants production data, a matter of understanding what people actually want to do with it and how they want to use it. But our aim is to collect all the data and then through our cloud platform offer out APIs. So we can work with Struxoft's Onyx, we can work with ERP systems. So you can track your coils through the machines, you can track your jobs and all those sorts of things. And actually then, because we give an API just with the raw data, it should be simple to integrate into multiple different systems. It's always been our kind of philosophy is we want to be open so that you can do what you need to do with it. As soon as we close it, it makes it really hard for everybody. So this is on all the Gen 6 machines that are currently shipping. We'll get this, and the older Gen 5 machines will have some limited features because of hardware issues and just older software. So that's what we're working towards. But for the future, and we're looking long term here, and it ties into some of the things we've been talking about today. So you could have all these machines networked. So we could have either an opt-in network or a dependent network for a company, and you've got machines all over the country. So say there is one of these situations where you are in California and you want to build some buildings here in Tampa, and Wolf's opted into the system, you'll be able to log in and say, I would like this job done, who can do this job? And they can accept the job if they've got production capacity. You can send all your design files or get them to do design files. So it gives opportunities for production as a service. So eventually there could be a host of machines all around the country, and if you want to do a job in this location, you can get the parts made. It opens up other features too. Say you've got a framing machine but not a floor joist machine. You could use this system to just order the floor joists for your job. So it gives a lot of flexibility, which is quite good. And also we developed this a little bit with one of our customers in Australia, and they are in 5 different locations and they use it for failover. So say there's an issue, staff are off sick and they can't do it, or they've run out of coil, or they've had a breakdown, they can bump a job to the next nearest factory. If it has to go out today, they can reshuffle and reorder. So it's quite an interesting process we can put together with this. And this is a longer term goal, and we're quite keen to work with everybody who wants to work with us on it as to what is the ideal way this should work. What makes it flexible? What is the benefit we can get you out of it? So that covers the software side of it. Now, we do a huge amount of things with customers all over the world. So we've got all sorts of weird and wonderful machines we do up. This is a small selection. But one of the things we notice, we go and watch people putting frames together. And when they want to put the blocking in, out come the hammers or the bits of wood or all these things where they just brute force things together. So we developed a little table with a pusher on it. So we can build the frame and push those panels together. We can actually also flip those fins around and pull the panel apart if you have to pull it apart, because that's where most of the damage happens if you ever have to do things. Little things like this, like it's not full automation, but it makes a huge difference to the guys assembling stuff. It takes all the load off the people moving studs around and things. So really good with the heavier gauges. Another product we developed internally for ourselves is our tipper bin, and we've got one on the fork truck over here if anyone actually wants to have a look at it. So we did it originally for our CNC machines because we couldn't find a robust system for moving all the swarf to the scrap bins. So typically what you end up with is a 44-gallon steel drum and some sort of complex method of tipping it, and the drum gets damaged and then it falls in the bin and it's just generally a nightmare. These are about double the volume because they're square. We can skid them round on the floor with a handle, we load them on the fork truck and tip them straight in the bin. And we use them for different materials too, so we use them for aluminium, steel and brass and other things that we're machining, so we can actually itemise the things for the right bins. So we use the smaller bins on all the new framing machines as well, so if anyone's got one recently, they'll have some of these bins. Feedback's been pretty good because they're really simple. You can just slide them out of the way and slide the next one in and carry on production. Again, a tiny savings. You're saving that 15 minutes where the guy's off emptying bins, because we have enough of them in our factory for the CNC that there's always a spare one, so we can pull 20 out and empty them in half an hour and then bring them all back in again. You've probably noticed the Excalibur product here. So this is something we've been working on for a while, and Warren down in Tampa is doing a lot of development on this for us. So we were looking for bigger buildings and how we could do it. And this gets you into the structural steel space, but you get a few benefits from it because it's lighter weight. It's pre-galvanized, so there's no painting, there's no welding, and it's an engineered system. So we can do spans of up to about 100 feet, depending on the combination of the beams. We also make all the purlins and all the bits. So we're trying to systemize some of these big box buildings that other people are doing. There's a whole lot of things we can do with it that are quite clever. So this particular building was one of the first prototypes we built. It's about 12,000 square feet, and the main structure with the crane was stood in about 4 hours. So we moved pretty quick on some of these things. It's a product that's in development, and it's something we're working on to try and get the finer points right, because there's still a few things, but it goes up well. We've done probably 10 buildings in New Zealand now, varying from quite smaller buildings up to these sort of sizes. But the biggest thing was speed. So the guys in the building next door went out in the morning in their trucks. They came back at the end of the day and there was a building there. Now, with your traditional hot-rolled structures, that just doesn't happen. Another product we've had for many years and we've been working quite hard with recently is our Speed Floor product, which is a composite concrete flooring system. So this is a good example of where some savings come. So it's a pour in situ system in this particular case. This building was designed, and we're pricing it up at the moment, with a pour in situ slab system, a traditional build. So 8-story apartment, 160,000 square feet. There's about $750,000 worth of our Speed Floor system in it. But we saved $9 million on the foundation because of the lightweight nature of the building. So we've gone from a 1-foot concrete slab to a 4-inch concrete slab. Because we use the steel where it's strong, we use the concrete where it's strong. It's a great composite system. So this one will be an interesting project to go through because there's other savings there as well. We can go up a floor every 3 days, and we're pulling weight out of those floors as well. It's not unique in how it works. There are other products, but they're fabricated and they're big, heavy welded products, where this is a roll-formed product, and it has all those advantages again. On the back of that, we've got our new system, which is a precast one, so we've got some patents on this that are currently pending, which we're just about finished with. But again, similar sort of idea. We can precast these floors in the factory, and we design them all around a truck width. So we go long, but we stick to standard truck width for movements. We've developed a system where they butt together and we grout them and fire grout them. But because of the way they're built and the steel strength in them, we don't really get any deflection. So that there, over, I think that was a 6-metre floor, we had less than 1 millimetre deflection with 1.5 tonne centre load on it. And we can control it because we're controlling the steel bit that makes it work. The concrete, we actually don't really care what happens in the middle of the concrete, we care about the ends where the steel are. So it's a really interesting product again that we're developing. So just to kind of give you a feel for some of the things we do that are not framing. So this we see a huge advantage to replacing hollow core, and we can do wall panels with it, we can do roof panels with it. You know, it's still a heavy product, but it's a much lighter heavy product. And the last one I'll show you is, again, another little weird thing we built. We made a 30-tonne servo press for a customer. And the idea for this was it's for prototyping and small, medium production runs. So it's a fully servo-controlled, basically like a framing machine as far as it's controlled. We can control pressure and stroke and speed. So for doing small production cycles, doing all of those really intriguing little brackets and things you want to run 500 of for a job, we can make a tool to fit in this press to do that. And it can have pneumatic ejectors, hydraulic ejectors. It can have a decoiler with it if you want, so it can become a mini production line. So in this particular one, we've got hurricane washers up the top. So they actually, what this customer does is they will use the same roof sheet that they're running through their roll former and make matching washers for colour match. There's a drum for a roller door and a bracket in this one as well. So we can just swap these tools out and do all sorts of interesting things in them. So that just gives you a flavour of some of the other stuff we're doing. And I've just got to say, it's been great to have everybody here and all these great thoughts and interesting presentations. I hope that everybody goes away with lots of things to think about. And I just want to thank Cindy and the team for putting all this together. It's been a huge amount of work to pull this together, but I think well worth it, and I hope you all agree.
And a huge thank you to all of the other sponsors for the event. Another shout out to Argos, Aerosmith, Strucksoft, Simpson Strong Tie. Thank you to all of you for making this event happen as well.